Okay, so for this video we're doing homework problem 15.5, parts B, C, and D. And we really did the hard work for part A. So part A, obviously you remember seeing that, right? We just did a ton of things. So the question was, first of all, verify that it's normalized. After we verified it was normalized, we found that we had, I think this was the important part, 3/16 times that, plus 3/8 times that, plus 7/16 times that. Gives 1, right? Well, so our question now then is for part B. In any single measurement of the observable that corresponds to A hat, the operator. This is postulate 3. Sorry, this is not the question. This is the postulate. In any single measurement that corresponds to this observable, the only values that are ever measured will be the eigenvalues of the operator. Okay? So it made no sense to us a couple weeks ago. And only now is it starting to have meaning. So what we got was, we started 15.5 out with the definition that this was our wave function. The wave function was psi, which was a linear combination of these three wave functions, which were all eigenvalues. We know they were eigenfunctions. We know they were eigenfunctions because the question stem told us they were eigenfunctions, and that's the only way. Okay, so hopefully these words are starting to take on more meaning to you. And not only were they eigenfunctions, they were orthonormal eigenfunctions. They were orthogonal with respect to each other. So that's when we figured out, well, since these guys are orthogonal with respect to each other, a psi1, psi2 component of this, a term is going to go to 0. A psi1, psi3 component is going to go to 0. Psi2, or rather phi1, phi2, whatever. It's going to go to 0. That's what ortho means. And normal means that they're normalized. Okay. So, and we used that part here. Since it was normalized, we knew that must be 1. And this must be 1. And this must be 1. So we got to 3/16 plus 3/8 plus 7/16 is equal to 1. All right? And that meant that the psi was normalized. All right. That was all part A. Now that we come back to the problem, part B says, what are the possible measurements? Well, we look back at the wave function and we go, well, whatever they are, they're eigenvalues of this. Well, the only possible eigenvalues that you have are the eigenvalue of this, the eigenvalue of that, or the eigenvalue of this, because these are the eigenfunctions, right? So look at this. The eigenvalue of phi1 is e1. The eigenvalue of phi2 is 2e1. By definition, that's just what we were given, right? And the eigenvalue of phi3 is 4e1, okay? So the answer to B is, I don't even have the question written here, I just have the postulate. The answer to B is E1, 2E1, and 4E1. Right? Because those are the only possible. Now, in order to appreciate that, you need to go back and read postulate 3. By the way, that shows up for the first time on page 334 for chapter 14. And the next time, page 354 for chapter 15. Your assignment is not done. You haven't got as much value out of this problem as you can unless you've already tried it. That's why you're watching this video. You need to read this postulate, go back and read these pages with this wave function in view. Okay, pull that out like I've got on a piece of paper. Read those pages and say to yourself, all right, well, these are my eigenfunctions of the operator E, and these are the eigenvalues. Therefore, these are the only possible measurements that we have. Okay, for postulate 3. Huge take home for part B. 15.5, frankly, is huge. It's surely 30% of our next exam, maybe 20% of our next exam is going to come from problems like 15.5. So really spend some time looking at this. Page 334, page 354, and read this question again. And this is a great example of an application for postulate 3. All right, so the next question was, part C, was what is the probability of measuring each of these? All right, so the probability of measuring each of these is, it just really falls out of our definition of normalization. The probability of measuring each of these is 3/16, 3/8, and 7/16. Right? Because again, our entire universe, as far as this measurement goes, is 100%. 1 means 100%, right? So 100% of the time, we're going to have either this or this, or this. So 3/16 of the time, we're going to have the measurement of phi 1. 3/8 of the time, we're going to have the measurement of phi 2. And 7/16 of the time, we're going to have the measurement of phi 3. Again, this is on page, I want to tell you that a full description of this is on page 335 and page 354. You need to read those. But let me give it to you here again. What's the probability of each of these? 3/16 probability that we're going to get. I'm going to answer D at the same time. 3/16 of the time, it's going to be E1. Right? 3/8 of the time, it's going to be 2E1. And 7/16 of the time, it's going to be 4E1. And I got those numbers from here. Right? From part A. I'm working on a part A. Okay? And that's going to be 100% of the time, which we call 1. Right? If you add these up, you get 1. 100% of the time is going to be one of those. Okay? So part D is, what is the average of E? So your author uses the series notation or summation notation for this, which is, I think, indispensable. I don't think we can do without it. So let's do this. The average value of E is going to be P1, which is 3/16. That's the probability of the first P1, E1. Okay? Plus P2, right? That's what the summation notation means. It's 3/8. That's the probability of situation number 2. And that's 2E1. You see, I started to set it up above here. Got a little ahead of myself. And then 7/16 times 4E1. That's the average. Okay? So this then ends up being 3/16 E1 plus 6/8. Let's make this 12/16 E1 plus 4 times 7 is 28. 16 E1. Right? Which ends up being 43/16 E1. That is the average value. That's the average over many measurements. Okay? I guess the point that you need to, the point, if this doesn't look familiar to you, perhaps you should go back and review what is meant by a weighted average. Okay? And I think I also want to point out that in 15.5, what we did is we reviewed ortho, normal, these two, and those are, concepts in and of themselves. Ortho, normal. We reviewed single measurements. That's postulate 3 from chapter 14. Okay, which we didn't really learn until now. Now's the time to do it. We learned probabilities. That's postulate 4. Okay, and we learned average values, which is also chapter 4, but I think that's also postulate 4. Either way, wow, 15.5 is a super problem. Glad you asked. Thank you to all of my fans out there. Wishing you the best. Thinking of you in this Christmas season.